Okay, in this lesson, we are going to be talking about adding and subtracting monomials and polynomials. And so there's a lot of definitions that we need to go over first. So the first one we're going to look at is the definition of a monomial. And mono means one. Okay, so we're talking about one thing. And this one thing is made up of a bunch of different things. So a monomial is an expression that is either a numeral. So a numeral might be like 14 or 12. Those are numerals. A variable, that could be y or it could be z, or the product of a numeral and one or more variables. So that could be like 2/3 r or -6x² y. These are all products. 2/3 times r, -6 times x² times y. So product means times. So each of these are considered to be monomials. They're one lump. Okay, so anytime we're multiplying stuff together, we can treat it as one lump. Okay, so these are each one term. These happen to be constants. 14 and 12 are constants. Y and z are variables. Here, 2/3 is the coefficient. R is the variable. -6 is the coefficient. And then x² and y are variables. Okay, so these all make up monomials. And they're either individual things or they're products. Okay, a polynomial then is a sum of monomials, and that includes subtraction because subtracting is the same as adding the opposite. So when we talk about a sum, in this case, we're also talking about when we subtract. So a polynomial is a sum of monomials. Poly means many, okay, which is usually just like more than one. We have specific types. We have a binomial, which has two terms, bi meaning two. Trinomial is three terms. And then anything with more than three terms, we just call them polynomials. So an example of a binomial might be x plus 7. Here's a monomial, here's a monomial. I'm adding them together. There's two terms. That's a binomial. A trinomial might look like this, x² plus 3x minus 2. I've got three different monomials there, and they're not like terms, so I can't add them together. So this is what a trinomial looks like. This is what a binomial looks like. Okay. Similar or like terms. Okay. Similar or like terms are the same except for their coefficients. Okay. Sometimes the coefficients are the same, but it doesn't matter. They have to have the exact same variable configuration. Okay. And you can only add like terms. And when I say add, I mean subtract as well. Okay, so you can only add or subtract similar or like terms. So if I have x plus y, they are not like terms, so I can't add them. But if I have 2x plus 7y plus 7x, they both have the exact same combination of variables. They each have one x, so I can add those together. And what I do is I add the coefficient, which is the number in front. So here I have 2x's, here I have 7x's. I have a total of 9x's. If I have something like this, x² y plus 2x² y, the combination of variables x² y are exactly the same. So again, I can add the coefficients. There's no number here, but we assume this is a 1. Okay, so this is 1 x² y, and this is 2 of them. So if I add them together, I get a total of 3 x² y. Notice that when I add, nothing changes with the variables. Okay, the only thing I'm adding are the coefficients, which are the numbers in front. And if there's no number in front, we assume that it's a 1. Okay, so those are like terms, also called similar terms. All right, if we have simplified or simplest form of a polynomial is when none of its terms are similar. So if I've got a bunch of stuff, okay, so suppose I've got this. I've got -6x cubed. There's one monomial. And I'm going to add 3x². There's another monomial. And notice that the variables are different. Here I have 3x's. Here I only have 2. They are not like terms. And to that, I'm going to add x², and I'm going to add 6x cubed, and I'm going to subtract 5. Okay, so here I have a polynomial, and I'm going to go through and I'm going to look for my like terms. And so one thing I like to do is I like to either like underline or circle. So here I have an x cubed, and I'm going to circle that. And I circle the whole thing, including the sign in front, because that's the sign of the whole monomial. So this is a -6x cubed. And then I look for others that are exactly x cubed. So here's another one that's exactly x cubed. I'm going to circle that, and I circle the 6 and the plus that's in front of it as well. Then I look at them and I say, okay, I can add the coefficients. Well, -6 and +6 gives me 0, so those just simplify to 0. Then I'm going to find the next one. So here I've got x squared, and I'm going to just underline it. So there's an x squared. Here's another one that's also an x squared. So I have 3x squared plus 1x squared gives me 4x squared. Okay, so I've taken care of this, 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 and this, and I'm left with -5. There are no other constants, so it's just -5. So simplest terms, or simplest form, looks like this. I have simplified it. I have added everything I could possibly add, and this is as simple as it gets. Okay, so that's simplifying. We're not really solving it. We're just reducing it to the fewest number of terms as possible. Okay. Then we have what's called the degree of a variable in a monomial, and that is the number of times that the variable occurs as a factor in the monomial. So for example, if I have 6x squared, the degree of this monomial is 2 because the variable occurs twice. Okay, so that's the degree of the variable. If I have the degree of a monomial, okay, that means the whole thing. So the degree of the variable is just that variable. If I have 6x squared y cubed, the x is degree 2 and the y is degree 3. Okay, because that's how many times they occur. And basically, we're just looking at the exponents. Okay, the degree of the monomial is the sum of the degrees of its variables. So here's a monomial. If I look at it, the x is degree 2, because there's 2 of them. The y is degree 1, because there's 1. Can't write very well. The z is degree 4, because there's 4 of them. We're just looking at the exponents. If there's no exponent, we assume that it's a 1. Okay, so if I add all these up, 2, 3, and 7, this is a 7-degree monomial. I can't even spell monomial. 7-degree, which means that basically I have 7 variables in here. If I were to write this out without the exponents, it would look like this. And I would have 1, 2, 3, 4, 5, 6, 7 variables. Okay, so that's what the degree means, is how many times does a variable occur. So if it's just the degree of the variable, you're looking at the exponent. If it's the degree of the monomial, you're adding all the exponents of all the variables, and don't forget the ones. Okay, everybody always forgets the ones. Okay, so then we have, fun, the degree of a polynomial. So the degree of a polynomial is the greatest of the degrees of its terms after it has been simplified. And this is the key. Simplify it first before you try to figure out what its degree is. So if we look at this, this is what I had on the other side of the paper. And we said that this simplified to 4x squared minus 5. Okay, if we look at this, we would say, oh, well, this is a 3rd degree, a 2nd degree, 2nd, 3rd. Okay, so we might say this is a 3rd degree polynomial. Well, it's not, because when we simplified it, we got 4x squared minus 5. This is a 2nd degree monomial, and this is basically a 0 degree because there's no variables. So we would say that this is a degree 2 or 2nd degree, if I can write, polynomial. Okay, and this is a polynomial. It also happens to be a binomial, but we can just say it's a 2nd degree polynomial. Okay, so that's what it means by degrees. And we don't really use degrees very much, but it's just kind of something that you should know. Okay, so I said before that this lesson was on adding and subtracting polynomials. Okay, we haven't really done a whole lot of adding or subtracting. Okay, but the main thing you need to know about adding and subtracting polynomials is similar or like terms. You can only add or subtract similar or like terms, which means the variable combinations have to be exactly the same. If they're not, then you can't add them. So if I look over here, there aren't any exponents here, so to try this should be fairly easy. Okay, and then we'll go over some of the classwork problems together in class tomorrow.